Hello, in this video let's discuss second and third question of today's contest. You are given an integer array of length n representing the weight of n parcels arranged in straight line. A shipment is defined as contiguous subarray of parcels. A shipment is considered balanced if the weight of the last parcel is strictly less than the maximum weight among all the other. Return the maximum possible number of balanced shipments possible that can be found such that each parcel appears in at most one segment. N is up to 185, the length is up to 185 and the weights are up to 189. So for example, let's take this array, and if we try to divide the array into three subarrays such that the last element is strictly less than the balanced in that subarray. So 3 is less than 6, 2 is less than 3 and 2 is less than 4. So the answer is 3 in this case. So let's take this example. If the example is 2, 5, 1, 4, 3. So 1 can be paired with 5 also because 1 is less than 5, and 1 can be paired with this also. Why? Because even now the maximum in the subarray without last element is 5. So 1 is less than 5 in both the cases. Even if we take 2 or it will not take, even if we take 2 or do not take 2, the answer will not change because the maximum is 5. So it will depend only on 5. We can take the subarray of length 4 or 5 or any as well. But even then it is same as taking subarray of 2 length because 5 is here. And similarly for 4, 3 we can take only simply 4, 3 because these two are the only elements left after taking subarray ending at 1. So the answer will be 2. And what are those two? It can be 2, 5, 1 and 4, 3 or 5, 1 and 4, 3 as well. So let's take the next example. So for example, we are able to take subarray of length 3, right? At ending at this index, we are able to take subarray of length 3. Do we ever have to take length 3? Or can we simply take length 2? Because if we are able to take the whole length 3, what it means? It means that the last element is less than the maximum in the whole rest of the subarray that we have taken. So then obviously it will be sufficient that the last element is less than the number before itself also, right? Because let's say this is 10 and this is 20 and this is 1. This is 1. So we can take 21 as well because 1 is less than 20, and we can take this also. Why? Even it is 1 is less than 20. For example, let's take other one. So if it is 20, if it is 10, if it is 13, and if it is 20, if it is 10, and this is 1. So in this case, if we cannot take 13 with any other one because we have 10 before, so we cannot take this, and we cannot take this also. Why? Because 13 is more than 10 in both. So hope you got this. Like we are thinking only with respect to 13, but 20 and 10 can be selected. Why? Because the last one is the 10 is less than the maximum number in the array. For now we are assuming that we are ending at 13 and we are thinking what the subarrays that can we take by ending at 13. So hope you got this. And similarly in this, we cannot take 10, 1. We can take 10, 1. Why? Because 1 is strictly less than 10, and we can take 20, 10, 1 as well. Even now 1 is less than 20. So in this way, if we try to observe, in this, what can we think of? So independent of thinking the whole subarray at once, we can simply think of the numbers at index I and I plus 1, so that we can simply select whether it can be taken or not by checking this element is strictly less than this element. And how are we sure that we will surely get the correct answer? Because let's take this example, 20, 10, 13. So 20, 10, 13, we are at this index. So we are thinking whether these two elements can be selected as a subarray or not. Can we select this? Obviously yes, because 20 is less than 10. So 20 is more than 10, 10 is strictly less than 20. So we can take this, so the answer is 1. These both are considered, so we will come to this. Are there any other elements left for 13 to pair with? No. So the answer is simply 1. So even if we take only length 2, we cannot miss our answer or we cannot reduce our answer. So if we are taking if this 3 as a subarray, we can take this 2 as 1. And even if we take these 2, then we are not going to reduce the answer by anything. If we try to reduce the subarray of length, then it can be more better or it can be same. Why more better? Because for example, we have these 4 and initially we are pairing these 4, but now we are thinking only with respect to 2, so we might get these 2 as well, so that it is going to increase our answer. So it is very simple to think in terms of 2 because the answer can be increased. So instead of thinking the whole subarray at once, think about every 2 indices. If these both satisfy the condition, then simply we got subarray, increase the answer, then go to next index. So I is equal to 0 to n, and check if the present element is, if the next element is strictly less than the present element, so that we can take the present subarray as 1. So if this is the case, then increase the answer and increase I, because we are looping I, because so that we can increase I to next index. So, and simply return the answer. In this case, we can simply return the answer. So let's discuss the next one. You are given a string s of length n and int is array order, where order is permutation of numbers. Starting from time 0, replace the character at index I with star at each time step. A string is active if the total number of valid substrings is greater than or equal to k. So the return minimum time t such that s becomes active. So this says that we have to find the minimum time such that the total number of substrings with at least one star is more than or equal to k. And the constraints are n is up to 1 if I and k is up to 1 in n. So least index in V such that we have number of substrings with at least one star is greater than or equal to k. So let's say we have string s of length 5 and we have vector v of length 5. So can we get answer at 0 index of v? Obviously we can get, or we cannot get. Can we get answer at 1? Even then the answer is same, right? We can or we cannot. But what if, let's say, we are at index 2 and we got the answer, and let's think of index 3. So index 3, is there a way where we cannot get answer? Obviously no. Why? Because at index 2 we are able to get the answer. At index 3 we are adding an extra star, which will obviously increase our answer, or maybe, or may or may not be increase the answer, but we are sure that we are unable to decrease answer. So for this we are able to get our answer. Then why we can't get answer for this one? Obviously we will get answer for this one as well, because we are adding more character, more star. So obviously our answer will increase, and obviously our answer will be surely yes as well, because answer is satisfied here. So from this, what can we think? So it will be surely a binary array, where 0 represents the case we are able to get the answer, and 1 represents we are unable to get. It will be surely increasing. Why? We cannot get, we cannot get, we will not get, we will not get. And at 1, let's assume we will get the answer. So at every index after this also, we will get our answer possible, because we are increasing more star. It will increase our answer, and at before index we got the answer. So obviously we will get the answer at this index as well. So in this case, we can simply think that we can use binary search on answer, so that we can get the least index such that the answer is correct. So low, mid, what is low? It is simply the 0th index, high is n minus 1, and let's assume mid is this. Mid is this because 0, 1, 2, 3, 0 plus 3 by 2 is 1, so mid is this. So let's assume that we are going to make all the indices from 0 to v of mid as star in the given array. So these both will become star. And now what to do? So now we have to find the number of substrings with at least one star. So it can have 1 star, 2 star, or any star. So in this case, which is better to think? So it is easy to think in terms of substrings which have no star, so that we can simply reduce the total number of strings minus the number of strings with no star, so that we can get our answer, instead of trying to find answer for 1 star, 2 star, and so on. So what is the total number of substrings? It is simply n into n plus 1 by 2. And now the main goal is to find the number of strings with no star, right? So for example, let's take this one and start iterating and getting our answer. So initially we are at A. So what is the number of substrings that we can end at A? It is obviously 1. Obviously this is the only string. And let's come to B. And now what will be the answer? What are the number of substrings that are formed till this? And we are thinking about only the strings that will not get at least one star. So they should be pure characters. So A, it is pure characters, so 1. And coming to B, so it will be B and AB as well. So we got 2 ending at B. So what is the total number of answer till AB? It is 3. And now we reach at star. So we cannot take any string that is ending at this. We cannot take any substring ending at star. And now let's come again to C. So if we are coming to C, then what will be the answer? It is only 1, right? We cannot take any starting index less than this, because we got a star. So from this, what can you observe? Let's assume this is the whole substring without any stars. And now let's assume this is star. And let's assume this is other group of pure characters without any star. So will the answer in this depend on answer in this? Obviously no, because we got a star. So these both are isolated. because we are thinking about a set of substrings with no star. So obviously these both are separated. If there are 6 substrings in this with pure characters, here the answer will not depend on 6. These both are isolated. And how can these both be found? This is simple, right? So this 6 depends on the length of the substring with without any character. For example, let's take again this one. So AB star C and then star again and then DF. So this is the given string. And now what are the group of substrings that we can think? This is AB, this is C and this is DF. What is the answer with respect to 3? It is simply the total number of substrings in AB, because we can get A, we can get B, we can get AB. So it is 2 into 2 plus 1 by 2. Why 2 into plus 1 by 2? This is simply the total number of substrings in AB. And what is the answer for C? It is 1. 1 into 2 by 2. And for what is this? It will be 3 into 4 by 2. It will be 6. Because D, E, D, E, F, E, F, D, F. So these 6 are answer for this. C is the answer for this. And A, B, A, B are 3 answers for this. And how can we write this? It can be simply written as 1 plus 2. Because answer ending at 1 is A, answer ending at B is 2. And similarly for DF, it can be 1 plus 2 plus 3. So if you observe this, what can be easily think of? It is simply the length of every string ending at that index. So we can start traversing the length, we can start traversing the string, and we can simply initiate L is equal to 0, and then we came to initial answer. We got a character, so increase the length and add answer to length, because now answer will be length will be 1 and answer will be 1 as well, because we got new substring ending at this. And let's assume this is also non-star character, and the length will be 2, and now answer will be incremented by 2, indicating that the total answer will be 3 now. And let's say we got star 0. So if we got star 0, we can make a length is equal to 0, because for the next group of strings, next group of characters, it will be same as this, it will be same as the new substring, new string. So simply we will get to this. If this is non-star, increase length and increase answer as well. In this way we can very simply find the answer. So low is equal to 0, high is equal to n-1. We are doing the binary search, and if this is true, then answer is equal to minimum of answer in this, because we want the least index. Initially the answer is n plus 1, so obviously the answer will be less than n plus 1. And high is equal to mid minus 1, because we achieved the answer for mid, we want the least index, so reduce high, so that we can get the least answer, we can get less answer. Else low is equal to mid plus 1. We are unable to get the answer for index high. How can we get the answer for less index? We can get only answer for more index, so simply increase low to mid plus 1. And finally, if answer is greater than n, it means that the answer is not updated, so simply return minus 1, else return answer. And now we are taking the new string, so that we will not make changes in the given string itself, and traverse from 0 to mid and make those characters a star. And now the total number of strings are n plus 1 by 2, and clean is the number of substrings with 0 stars, and length is this one. The length is the length of substring without any characters, without any stars. So start from 0 to n. If the present character is star, then make it as 0, because we will not get any good substrings for now. Else, it means that we reached a good character, and then increase the length. Why increasing the length? Because we are at A or B or any till Z. So we got a new length to add in the answer. So simply increase the length and then add this to answer. And finally return total minus clean. If this is more than or equal to k, return 1, else 0. So in this way we can find the answer. So let's discuss another example. So let's say we got star, AB, and star again and C. So how can we find the answer? So initially the length is 0 and we are at star. So we are at star, so don't need to make any changes, because we will not get any substring ending at this with no star, because this is obviously a star. And let's come to this. So this is not a star, right? So we can increase the length. So we are starting a new string here, because till now there is no length. So we are making length is equal to 1. So this is the new one. And what will be the answer? It will be 1. And now we got other string, so increase the length of this. So this is the new string without any stars. And what will be the length now? Length will be 2. Why 2? This is B and AB. So add this to the answer as well. So simply 3. In this way, we are able to get the number of substrings without stars. If you have any doubts, comment below. See you in the next video.